of mapping existing data structures to Fhir. And it's difficult to do that in a reasonable amount of time in a presentation because it's not a short process, and it gets fairly detailed into writing code and stuff like that. And not all the attendees today are necessarily going to be interested in that level of detail. So what I did do is I put together a set of links to different articles or exercises that walk through doing exactly that using different technologies and different approaches. There wasn't a heck of a lot out there in terms of demonstrations for integration engines. Most of the places that have that said, sign up here and we'll be happy to schedule something for you. So it's more of a marketing exercise than a here's free demonstrations of how to make it happen with our product. But there was one, and then there's exercises showing how to do it with some of the different reference implementations and commercial Java and .NET solutions out there as well. So hopefully that will be helpful. There was also a question whether there were particular Fhir servers that are more recommended to work with. And there's two main ones. There's the Happy Java server, and there's the .NET Bonk server. Both of them are widely used in production systems. I don't know that there's necessarily a strong market push towards one or the other. It's sort of more a question of which technology platform do you prefer to work with. They're both pretty capable, and they both keep up pretty well with the Fhir specification and are pretty functionally complete in terms of what they can do. I mean, you can certainly seek out recommendations from people on chat.fhir.org in terms of particular considerations for your implementation space, but as a general thing of which one is better, I don't know that there is one. There are other technological solutions out there as well that aren't necessarily as widely implemented, but I haven't heard anybody come and say, this particular server totally sucks and you shouldn't use it. That's not something I've heard. Not necessarily something I would hear either, though. Second question is, what does a project look like? What do you start with? What are the steps in the process? And that kind of depends on what is it that you're trying to do, because there's a number of different ways that you can approach rolling out Fhir. I mean, you can decide that you just want to build a Fhir interface to expose your data. You can write a Fhir interface to consume data from others. You can focus on exposing Fhir documents. You can build Fhir messaging. You can build Fhir REST. I'm going to assume that your primary interest is in building Fhir REST because that's sort of the ideal end state for most spaces. And there it's decide on what kind of a facade technology you're going to want to use. There are different approaches. There's approaches where you actually have a full-blown Fhir repository that you synchronize with your existing data structure and use tooling to do that. You can also build a facade directly on top of your existing database and have conversion processes that transform the incoming searches and that transform the outgoing data. And you don't have to start from scratch with either of those. You can use integration engines. It's entirely possible that your organization is already using an integration engine that supports Fhir. So that would probably be the first thing to start with. In terms of technical skills, you should have somebody who understands JSON and XML, which isn't terribly hard to find these days. And you probably already have some people who fit that bill. You'll need somebody who understands the HTTP stack, including all of the HTTP security stuff. So how to do TLS, how to do OAuth. There are libraries that will help you with most of that, but you want somebody on hand who will be able to diagnose when things go wrong, because something always goes wrong at some point. Most of your work is really going to be in the data analyst space. figuring out where best to expose particular data elements, how to map terminologies, because that part is really hard to automate. That requires internal knowledge of your data structures and how you use them, and what are the ramifications of exposing them in place A versus place B in the FHIR spec. How is that going to look to other systems? Is it going to be consistent with how other people are using FHIR? Are receivers going to get the relevant information and be able to pay attention to the relevant information? And that's just analysis work. And you don't normally try to do everything at once. You pick certain sets of data where you have a couple of consumers who will be able to use it in short term, so that you're actually targeting a particular customer and exposing the data that's relevant to them and their use case. And then over time, you grow what you expose. So that is a quick summary of what the process could be or often is. And you will find videos and tutorials that sort of walk you through some of those steps in different environments and with different considerations. But without knowing more about your specific situation, it's hard for me to provide more guidance on that. And the last question is, should I start before Israel has published Israeli core? Yes. The notion of having an Israeli core is to define things like what are the drug codes that we're going to use in Israel, and what are the condition codes that we're going to use in Israel, and are there any special extensions that we need to support regulatory requirements or cultural requirements or whatever that is unique to our space, but is relatively consistent across all of the different HMOs and different healthcare services in the country. But you can absolutely start work before that's nailed down, because even if you haven't landed on what code system do you need to translate your drug codes to, you will at least know that I need to have a drug code and it's going to be here, and the one that I have internally is this. And so start with exposing that, and you can add on a translation that includes whatever it is you as a country land on, or maybe it's pretty obvious where you're going to land and you don't need to even wait for that discussion to happen, because you know that in Israel drugs are you going to use code system X. And the other benefit of starting now is that Israeli core is not going to magically appear as a message from heaven that this is what it should be. It's going to be a discussion amongst the community of what can we do, what is reasonable to achieve, what kind of data do we already support in our systems that we can expose as FHIR. And the more work that you do internally in terms of exposing the FHIR interface, the more knowledgeably you'll be able to engage in that discussion and guide it in a way that's actually going to work for your environment. So absolutely get started sooner. But whatever you do in FHIR, you should build in a mapping layer that will support multiple versions of the interface, because there will be multiple versions of the interface. Israel core will come into play, and it will evolve based on experience in the real world. There are parts of FHIR that will change, at least somewhat, between release 4 and release 5 when they get locked down, and there will be other parts of FHIR that are not yet locked down. Family member history hasn't been widely implemented and maybe revamped a fair bit. I'd be surprised if it got revamped radically, but given that it hasn't been widely exercised yet, we can't be confident that it's stable. And so you will want to have a mapping layer in your system to accommodate that. But if you sort of wait until everything is totally locked down before you start, then you'll be left far behind, and you may have serious trouble catching up, and you'll lose out on all of the benefits that you can get from FHIR now. because there are a lot of benefits in terms of just getting information to flow, in terms of being able to embed externally built apps, in terms of being able to explore other markets and other things like that. And if you wait till everything's locked down, that could be 10 years from now, because we're still going to be introducing brand new resources in public health and other areas that we haven't really tackled yet. So thank you for those questions. And as I said yesterday, feel free to keep them coming. This session is for you, and I want to make sure that you're getting what it is that you want out of it. We left off yesterday talking about US core, and we were looking at one of the profiles. I've actually swapped profiles on you. We're now looking at a profile and observation, talking about lab rather than patient. And we were looking at how do you read this. And so we talked about must support, we talked about cardinality. I want to talk about a couple of other things that are better highlighted here. One of them is something we call slicing. So we've got an element here called category, and it's defined as one-to-many. And then we come along and we say, in this codable concept, we're going to say that you need to have a coding that has this fixed value and this fixed value. So what slicing lets you do is when you've got a repeating element and you don't want to lock down all of the repetitions, you don't want to say every category that you have has to say that it's laboratory, and you don't want to say you're only allowed to specify one category, because you might also want a category that says this is oncology, or you might want a category that says this is internal or external, or this is targeted for Department 1 versus Department 2. There's all sorts of ways you might want to categorize things that would be useful for workflow. And so we don't want to lock them all down. We want to, but we still want to ensure that amongst all of the repetitions that are present, at least one of them is going to say that this is a lab result, because it's useful to be able to filter your observations and distinguish the lab results from the vital signs, from the psych assessments, from various other kinds of things. And this code is what lets you do that. The slicing doesn't force any particular order. So laboratory could be the first category in the list, or it could be the 7th category in the list. We don't care, and you shouldn't create systems that care, because there's no meaning to the order of the categories. All that matters is that it is one of the things in that list. A few other things to talk about. We've got a vocabulary binding here. This one says that these are the codes, and then there's a little plus sign, which means, hey, there's more. And if we go click on that, we will come to a value set. And a value set is a collection of codes taken from a code system that are relevant in a particular place. In this particular situation, we're grabbing all of the codes from the code system, but that won't necessarily be true all of the time. This code system has a tiny bit of hierarchy to it. So corrected is a type of amended. And we're saying this is a set of codes that are allowed in this space. And furthermore, we are saying that you have to use these codes. On the other hand, down here for observation code, we point to a value set that says link codes. And here, we don't actually list all of them, because there's a heck of a lot of codes in the link code system. So we just expand some of them to give you an idea of what's here. And as link continues to evolve, those set of codes are theoretically permitted here as well. There are going to be some codes in LOINC that aren't actually relevant for lab. They could have been more prescriptive, but LOINC doesn't give a super easy way to say only the LOINC or only the lab relevant LOINC codes. And so they just said, yeah, any LOINC code is fine. But they didn't say that you had to use LOINC and only LOINC. They said that this was an extensible binding, which means that if you need to send a lab test that LOINC has no clue how to deal with, you can do that. There are 4 binding strengths defined in Fhir: required, extensible, preferred, and example. Required says you have to use this, you can't use anything else. If you can't pick a code from this value set, then you can't send the element. Extensible says try to use a code from this value set. If one of them applies, you have to use it. But if none of them apply, then you can send some local code, or you can send plain text. So to be interoperable, there is a value set that you should be able to use most of the time, but we recognize that the world evolves and there may be situations where you can't use our set of codes. Preferred and example have no conformance expectation. Preferred says we would like it if you did this, but we can't make you, and we can't get enough consensus to make you. So if you want to interoperate with most people, then use the preferred one as one of yours at least, but don't count on it always being there. An example says we don't really care what you use, and it's not even necessarily something that we can standardize. As an example, if we were at the international level trying to standardize billing codes, there would be no hope, because every country, every payer, every organization tends to have their own, and there's tons of politics bound up in the notion of billing codes. And so we're never going to standardize those on an international basis. And so the best that we can do is say, well, here's an example of some of the kinds of things that you might choose to use in your environment, but not necessarily something that you have to use in your environment. Other things to be aware of when you're trying to read these. Here we have a choice type, so in an observation, the result of the observation could be a quantity, or could be a codable concept, or a string, or a Boolean, or integer, or various things, depending on what type of lab test it is. And what will show up in the instance is value quantity, or value codable concept, or value string, depending on the data type. In this case, subject is a reference. So we don't actually embed the patient inside the observation. Instead, we include a pointer to it with a URL that says, here's where you go and find the patient. And think of it like a hyperlink. So in a hyperlink, you've got the URL, and you've also potentially got a display value that a human user would see. The reference data type does exactly that. So if you go look at reference, and yeah, it's not going to jump because it's the entire thing. There is a URL that points to the specific resource of interest. There might be a type that says, hey, this thing is going to be a patient, or this thing is going to be an observation. Sometimes you don't have a URL because you're inside of a message or a document, and the data that you're pointing to doesn't necessarily have a URL in the outside world. So you can specify just a business identifier, and you can specify a string that says, what should I display to the end user before they click on the hyperlink? So for the patient case, you would probably have the patient's name, maybe age and gender, just to give people a clue of who the patient is, and they don't necessarily have to click on the link to see that. So that gives you a sense of how profiles work. If you see something in here and you're not sure what it means, this little question mark takes you to a walkthrough that explains how to read all of the content, all of the flags, all of the other information that's in this presentation. So all of these little symbols along the left-hand side, there's an explanation of those. And so you can use that to help understand what's going on in these different renderings. I'm gonna jump, actually, sorry, that's not
Lloyd,
right.
can I ask you
Yes,
a question?
absolutely.
Let's say tomorrow we're opening up a first working group about Israeli core. Should we use the US core as the draft or the general fire specification as a draft?
Yeah, I would probably use that as a starting point. There's actually work underway on a higher level core that's intended to be international. But I don't know that it's gotten far enough for you to necessarily use yet. And in terms of what most of the other core implementation guides from various countries are doing, driving from US core and then saying what is different for us makes sense. And a few reasons for that. One is that a lot of the international vendors are already familiar with and already supporting US core. So if you keep your delta with US core small, that will make them happy and also mean that they will support your interface much faster. The other is that there's lots of apps out there. And the closer you are to US core, the more likely it is that those apps will be able to run in your environment or run in your environment with minimal change. And so that's something that's going to be important, is to make it as easy as possible for apps to run in your space, because if all of the apps that are out there run only in US core and can't run in your Israeli environment because you've made too many changes and enforced too many special things, then you won't be able to take advantage of all of that good content that's out there.
Lloyd, but just to clarify, it doesn't mean that they're taking the US core and extending it or building a subset of it.
No. When US core says things like drug codes must be from RX norm, and that's a non-starter in most countries. Certainly it is in Canada, because RX norm isn't driven by the Canadian Healthcare Agency, and same sort of thing in other countries. And some countries have access to SNOMED. US core makes heavy use of SNOMED, but if you don't have a SNOMED license, that gets really pricey really fast at a national level. So, and again, the extensions that we looked at yesterday with realm and ethnicity, it's unlikely that Israel cares a great deal about what kind of Hispanic ancestry its citizens have, and it may very well care about other kinds of things. So starting with US core means that you look at what are the elements that are present. So if we look at lab, for example, in this profile, you would probably say, yes, statuses must support, and yes, it's reasonable to require that there be a category on a lab result that says that it's lab. You may or may not be comfortable using LOINC. LOINC is pretty international and it's free, and it's supported by a whole lot of lab systems in terms of software out there. Subject, certainly pointing to patient makes sense. You might want to be broader than that, but probably limiting it to patient makes sense. In the base resource, subjects can be all sorts of things, but the scope of most implementation guides that are focused on core is human patients. But you would be pointing to the Israeli patient, which would have slightly different extensions and perhaps different expectations. The rest of it, probably not that different. So the only thing that you may be looking at changing in terms of US core lab observation is binding to LOINC reasonable in our space? Is that something that most systems would be able to at least map to? And changing the patient to be your particular profile and patient. But other than that, most of what's here is probably going to work relatively well in the Israeli space. Excellent questions. Next thing.
Sorry, I would just want to clarify something. While you refer that there are talks about making international codes, do you refer to OMOP CDM or something else?
So in terms of codes, for most of the major code systems, so things like allergies, drugs, observations, procedures, there is no effort underway to try to agree internationally on what that set of codes should be. There are several countries that are have purchased licenses for SNOMED CT and are using that, but even there are SNOMED CT variants in each country. So even if Australia and Canada and the US and the UK all say we use SNOMED CT for procedure, that doesn't mean that they're actually leveraging exactly the same set of codes. And there are other countries like Germany that don't have a SNOMED CT license and don't use it. And even in the US, where they have a SNOMED CT license, for procedures, they say, well, you can use SNOMED, but you can also use CPT codes, which are maintained by the American Medical Association and are heavily used for billing. So there isn't really an expectation that internationally we will have standard codes for the big terminologies, but we do try to mandate standard codes for smaller terminologies. So things like observation status, we think that it's reasonable for existing lab systems to map whatever their internal status codes are to the set of 10-ish codes that we have defined in Fhir, that's a mapping that is achievable and not so expensive as to be unreasonable. Whereas saying that every lab system in the world must map their internal content to length is a bit more of a stretch and not something we can necessarily impose. Did that answer your question?
Yeah, thank you.
Awesome. So the next thing I want to do is go take a look at the artifact list and specifically jump to capability statements. Capability statements are something that you'll see in most implementation guides, and they define what the expectations are for systems that want to claim that they conform with this guide. And there's two capability statements defined in this. There's what do we expect servers to be able to do, and what do we expect clients to be able to do. And in US core, the expectations on the server are considerably tighter than they are on the client. Client is basically, you should be able to consume our stuff without blowing up and use the things that you find useful. Because it's fine to be a client of US core and only look at the meds and the patient demographics because that's all you need. We're not going to force a system that's trying to display a med list to also be able to grab the list of procedures or grab the patient's goals because that's not relevant to them. On the other hand, for the server, we sort of expect that they will expose a fair bit of stuff. So if we go take a look at this, and again, all of these are actually resources, so you can download them in computable form, but we'll look at the pretty human readable view. And this is probably the most useful. This goes through and says, for these resources, these are the profiles that exist. These are the search criteria that we expect you to support. And one of the things that you can do in Fhir is you can, when you do a search, you can bring back other resources. So this says that in addition, when you're bringing back a condition, you can also bring back provenance that points to that condition. So you have a little bit of information about who created this record and maintained it and where did it come from. When you're bringing back a prescription, you can also bring back the medication that the prescription is for, because if you've got a prescription record that says, hey, this is a prescription to take 2 tablets of X, it's kind of helpful to know what X is. Most of the time, the medication is actually going to be contained inside the medication request, or it'll just be a code. But if you are ever pointing to an external formulary, you want to make sure that you're bringing the medications back. practitioner is sort of a linkage resource, and it indicates somebody who's working on behalf of an organization. And for this, you can bring back the practitioner as well. So this goes through and sets expectations in terms of what must you be able to do, what are the operations you need to be able to do. So for allergy intolerance as a server, you must support it. You must specifically support search and read. Ideally, you'll also support read for a particular version and retrieving the history. And it's fine if you support these other things too. And so it calls out more specifically, this is the capabilities that you're expected to have as a compliant system. And we go through and do that for every single resource that's defined in US core. And that's part of what you would also be validating in creating creating an Israeli core is it reasonable for us to expect that all systems in Israel would be able to support search and read on care plans. Now, as it turns out, if you go look at the US core care plan, it's not terribly ambitious. It lets you say that, hey, this is an assessment plan, and convey what the status of the plan is, convey a narrative, and indicate who the patient is. So essentially, you're being able to share a text blob that is a care plan. But the expectation is that in the US, if you want to claim conformance with US core as an EHR, which you kind of want to do, as otherwise you're in regulatory trouble in terms of penalties and such, then you need to be able to share care plans at least as a blob. Doesn't mean that you can't do all of the other wonderful things that care plan allows. And if you take a look at care plan overall, there's a whole whack of stuff that it can do, none of which is marked as must support. You can do those other things as well, but at minimum, you need to be able to pass around the text blob. So that's the level that the US community figured that they could get reasonable near-term interoperability on in terms of care planning. The other thing that US core has defined is search parameters. And so they've gone through and said, these are the specific search parameters that we expect there to be support for and how they're going to be used. So allergy intolerance, they say that you can specify multiples. So I'm interested in multiple and is actually a weird thing for them to declare here. That's a bug because you can't ever have something that is status of active and inactive. That would make sense, but or make sense. And even comparator makes sense. So they're saying this is a search criteria that you can use, and this is what it corresponds to. So when you are searching with the code in the URL of clinical-status, that's corresponding to the value of clinical status, and that will follow the token rules for search. So if you go into the core specification and go take a look at RESTful search, there is a definition of all of the different ways that you can search for information on a URL. And token is one of those. And token says you can specify a code or you can specify a system and a code. And there's some qualifiers there in terms of matching on text or matching using subsumption and stuff like that. Not all of that will be relevant for something like status, but as an example, you could, using SNOMED, say I'm interested in all of the patients that have diabetes or have a condition that is a specialization of diabetes. So diabetes mellitus, diabetes well controlled, and the system would automatically find all of the codes that are specializations of that and return them to you. And that is what defining a code system does. And now I'm going to go back to where we were yesterday. well, actually, no. What? Rather than going back, I'm just going to copy the URL because that's going to be faster. If you remember yesterday, we were looking at Epic and poking around various places in their test environment. Every single FHIR server, in fact, this is the only thing that a FHIR server must do, is they must have an endpoint beneath their base. So the base for the R4 stuff in Epic is this. They have to have something beneath that that is metadata. And that is what returns the capability statement for that particular server, which means that you can point your client system at any arbitrary server and find out what it does. And so here we can see these are the types of security that we support and where you go to get your OAuth tokens. This supports adverse event, and specifically it supports read, it supports search. You cannot retrieve history. You cannot do conditional creates, conditional updates. In fact, you can't do updates or creates at all. You can search by study and seriousness and subject, and that's it. On the other hand, with allergies, you can create them. So external systems can actually record allergy instances into the Epic environment. They can also retrieve a particular record or search. They cannot retrieve history of the allergy, and they cannot do conditional create, et cetera. And that goes through for every single resource that this server supports, what exactly you can do. So as a client, the first thing that you do when you're given a particular server endpoint is you hit that capability statement and say, what can this system do? And that can actually be a dynamic statement, because if the system is configurable, as Epic certainly is, then if somebody changes the configuration, then what gets exposed in the capability statement will be different, possibly in the morning than it was the day before. So that's what I wanted to talk about with US Core. Any further questions on that? Next thing that we're going to do is we're going to jump into some of the validation capabilities of FHIR. All right. So one of the things that you want to do when you're talking about a standard is be able to validate whether or not a given instance complies with that standard. So we saw a whole bunch of rules around cardinality and around what elements can be present and what codes they need to draw from and that kind of stuff. But that's only useful if you can confirm that systems actually do what they're supposed to do. So I want to talk with you a little bit about some of the different approaches to validating instances in FHIR, because there are more than one way of doing that and what the different capabilities are within that. We're also going to drill into terminology, because terminology plays a pretty significant role in validation and is one of the harder things to do in validation. And then we're going to take a little bit of a side trail to talk about FHIR operations, because we actually make use of FHIR operations when we're doing a number of terminology things. So let's start back at US Core, because one of the things that US Core provides is a downloads tab. Yep. Oh, whoops, we're in FHIR, not US Core. There's US Core. So they have a downloads tab. And on the downloads tab, one of the things that they offer is a package. And that package, kind of a sucky name, contains all of the computable artifacts that are defined in US Core. So all of the profiles, all the value sets, all the capability statements, you name it, in JSON form, optimized for computability purposes. And so if you download that, I'm not going to because it'll take me a couple minutes and I don't want to wait. And you then go to the Fhir core specification, and you go to the downloads page there, which we already explored a little bit yesterday, looking at the reference implementations. But something else that is here is the official Fhir validator. And if you download that too, then you can do this. It's command line, exciting. So the download from HL7 is going to be this validator client jar, and the package, which I've downloaded a few times, is going to be this package.tgz, and I can then point that at an example. This is an example that I actually got from US Core, but I tweaked it a little bit so it would say something interesting, because oddly enough, all the examples in US Core don't have any validation problems. And what's the fun of that? I'm going to kick this off. It takes a little bit to run. Don't be scared about that. Most of the initial time here is loading all of the base stuff. And if you were using this at runtime, you would launch your validator and load the base standard, R4 in this case, and any relevant implementation guide. So all of that's sitting in memory. So all you're really needing to do is parse the example and validate, and that takes like milliseconds. This is used in production in a number of places, and it works fine. But we come back and it yells at me and says, hey, the ethnicity that you provided is not valid, because I went in and changed the ethnicity to be Martian. And it says that's not something that's recognized. And you're also drawing from a code system that's not allowed. So this is what a validator is for. It can go through and check things that schemas can't necessarily check. So it's also yelling at me about the fact that there's a rule that says you need to have either a patient given or a family name, and I didn't provide either of those. I just provided a prefix, and so it's yelling at me about that. Let's go into the HL7 Fhir spec. If we go to the documentation tab, there is a section here on validating resources. And there's a handy dandy little table that talks about what are the kinds of things you might want to validate. So ideally, you want to be able to validate that the structure is valid. So you've got the right elements nested inside the right elements with the right names. You want to check cardinality. You want to check that you're drawing content from the right space. So you've got integer values in integers, and you've got code values in codes. But you also want to check that the bindings are valid. So is this in fact a valid LOINC code based on the current version of LOINC, or is this a valid SNOMED code? And furthermore, if the value set says all SNOMED procedure codes with body site of lung, is it in fact a SNOMED procedure code, and does it have a body site of lung? You want to check your invariants. So if there's a rule that says you must have a given name or a family name, do you have at least one of those? You want to check that all of the profiles that are either declared or that you explicitly say at the time of validating that this is a profile this thing has to be valid against, that it is following all of those rules. If you're doing questionnaires, we're going to take a look at those later this afternoon, that they actually correspond to their questionnaire. And then there's business rules. And so if you go look at the different validation technologies, we've got XML schema, we've got schematron, we've got JSON schema. If you're doing RDF, then there's a validator called checks. And then there's the Java validator. And XML is pretty good at checking structure for XML stuff. Obviously, it's not terribly helpful for checking JSON. And similarly, JSON schema can check JSON structure, but not XML. It can check cardinality. It can check to make sure that your integers are integers and your codes are codes. Can't really do bindings though. So schema is not going to know what all of the length codes are, and certainly isn't going to be able to figure out whether your SNOMED code is a procedure code with body, site of lung. Invariants, Schematron can do those, or at least do most of those. There are some invariants that we have that Schematron can't handle. And with Schematron, you can kind of do profiles, but there's a number of things in profiles that can't be handled by those technologies. And so when we do our validation, we do all of our validation with the Java Validator because it is FHIR aware and it is terminology aware, and it can do all of the things that we might want it to do. That doesn't necessarily mean that you want your validator to do all of those things, because checking terminologies may mean hitting an external terminology server to say, hey, as of today, is this a valid drug code? And hitting an external terminology server has a cost in terms of performance and in terms of bandwidth and stuff like that. And depending on your environment, if you're processing hundreds or thousands of instances a second, going out and hitting an external terminology server all the time might not be what you want to do. Maybe what you do is you just pass the instance through after a very quick check that it seems somewhat sane, and then see if anything blows up internally. And if it blows up internally, then retrospectively, you'll run a full validation on the instance so you can provide some better information about what specific problems are, but not be proactive. Or maybe you do validation, but you cache the terminologies that you're going to use locally so it doesn't need an external server. Or maybe you check certain elements, the ones that you care about, but you don't check everything because you could really care less if the elements that you're going to ignore anyhow happen to be invalid. It doesn't matter to you. So there's a number of different things that you can choose to do when validating to optimize that process for your space. The Java Validator is open source. There's an equivalent validator in the .NET platform. It's not quite as up to date, but they have a common set of test cases, so that they're working towards the same set of rules with both, and so you can use either in your environment. And we certainly use this when we're creating implementation guides and doing testing. I'm going to come back to the presentation and talk a little bit more about terminology. There's two main resources in FHIR that deal with terminology. We've got code system and we've got value set. And the simplest way to understand them is to think about code system as being a dictionary and value set as being a subset of codes from that dictionary that you're going to use for a particular purpose. Your value set is always going to draw from a code system. You can't have a value set that uses codes that aren't from some code system somewhere. The code system has to exist. It might not be exposed as FHIR, that's fine, but it needs to be recognized as being a code system. The code system is where you have not only your full list of terms, but their definitions. So what does pride mean? What does envy mean? The value set, on the other hand, is an enumeration that says this is the set of codes, the set of words that is allowed in this particular space. So code system might include things like SNOMED CT or ICD-10 or UCOM, which is a code system for units of measure. Your internal proprietary lab codes are a code system. They don't have to be official, registered, externally maintained things. If you have a Dr. Bob and they have a set of codes that they use for describing a particular type of tumor, that is a code system. It may be that nobody else recognizes it or understands it, but that is still a code system. Your value sets, on the other hand, are targeted at a particular use case. And how big or small that value set is depends on where you're using it. You can have extremely tight value sets, or you can have extremely broad value sets. For example, all procedures that could be done in Israel might encompass surgeries, it might include physiotherapy, it might include smoking cessation counseling. All of those fall within the realm of procedure in Fhir, and you could have a value set that draws from all of those. But your procedure codes would not include diabetes, because diabetes isn't a procedure. And that's what you're doing when you're creating a value set, is you're including the things that are relevant and excluding the things that aren't. There are, however, situations where you don't want to provide a complete list of all of the codes because it's too darn big. You would not want to have a value set that listed every single SNOMED procedure code, because there are hundreds of, well, I don't know if hundreds of thousands, but certainly tens of thousands of them. And if you get into post-coordination, then there are probably millions of them. Just too scary. And furthermore, it changes, and it changes by country, and it changes by date. And so it's more efficient to specify an algorithm. So specify the set of filters against the dictionary that will select the words that you care about. Sometimes the filter is just give me everything. So all LOINC codes basically points to the LOINC code system and says, yeah, all of that. No filters, just give me everything. Other times you'll provide a filter or maybe a whole set of complex filters. So I want all the codes that are specialization of this diagnosis and these three other diagnoses. I don't want their specializations, and I want this other code from this external code system. And that's something else that you can do, is you don't have to draw only from one code system. You can say, I want ICD-10 codes, plus I want this local supplement, or I want my internal lab codes, plus these others from LOINC, plus these others from some third-party code system, and that's completely fine as well. Generally, if you do that, you want to try to make sure that there's only one way to represent a particular concept. You don't want to have the same concept represented in multiple code systems, because then you have interoperability problems, where system A sends code from code system 1 and system B sends an equivalent code from code system 2, and you check to see if the codes are equal, and the answer is no, even though the meanings are equivalent. You can manage that a little bit with code mapping, but it's not something that you necessarily want to use all the time. So let's go take a look at terminologies in the spec. So multiple screens are awesome, except when you can't find your mouse. If we go back to the home page and scroll down, one of the things that we have available is the terminology module. And so that gives an overview of what are all of the different terminology artifacts. So this is a similar kind of view to what we saw previously. We've got code systems and we've got value sets, but this brings in a bit more stuff. We've got element definitions, which is part of what you see in profiles. So when you see that observation.code binds to a value set, that is an element definition inside our profile. And then we actually have an instance. So a codable concept or a coding or a code, and that's going to be tied to an element in a profile that it conforms to. So I've got a real world lab result, and it has an observation.code, and that observation.code is expected to adhere to the US Core Lab profile, and specifically the fact that US Core Lab says you need to draw your codes from LOINC extensively, so in some cases maybe not. And this particular coding in this specific lab report is going to refer to the URL of the code system. And that then ties everything together so you can validate and make sure that, yes, these codes, the code that I have is in fact valid against this profile. Terminology also supports mapping between terminologies. And we talked yesterday as well about naming system. We have naming system for identifiers. You can also use naming system to just do a quick lookup of the URL for terminology. So if you're not sure what the proper URL is for ICD-10 or SNOMED or LOINC or whatever, you can do a search on naming system without bringing back the full content of the code system, which sometimes is not something you want to do. In addition to that, there are operations defined. So if you want to be able to perform code translation, there's a way to do that. This is not a simple RESTful query, because we're not wanting to search and retrieve a code system or retrieve a value set. Instead, we're sort of doing a remote procedure call, and we want to pass in a concept map. So what is it that we're using to drive the translation? Because different systems might have different mappings that they prefer to use. So let's say that we want to go from ICD-10 to SNOMED. We would point to a map, or perhaps a particular version of a map that we want to use in doing that translation. We pass in our code, so some particular ICD-10 code, and a code system that says, hey, I'm ICD-10. If we wanted to, we could also pass in a version. We don't often need to do that. Some code systems are poorly behaved, where the meaning of the code changes from one version to another, and therefore the mapping might change from one version to another. And so if that happens, then you might need to pass in the version as well. We can also pass in the context. So in what context is this being used? Because there are situations where how you translate it depends on where it's appearing. And finally, we want to identify what code system we're wanting to translate it into, either a value set or a target system. Sometimes we also have dependencies. So maybe the translation is going to be informed by other elements. So I'm trying to translate a condition code, but I also need to know the severity, or I need to know the body site, because that's actually going to determine what SNOMED code this thing maps to. And in the end, I will get back the code that it maps to and some information about other elements that might also need to be filled in, like severity or body type, and a code that tells me how good is this match? Is this exact? Is this broader? Is this narrower? And the details here don't matter that much. I don't expect you to understand all of them or pay attention to all of them. The key thing is that you can do this in Fhir. You can define operations that you pass in a set of parameters and you get back a set of parameters. This particular one is an idempotent, which means that you can call it over and over again. It's not going to change the state of the system. There are ones that will change the state of the system. That will actually create data or modify data. And so this has the benefit of being able to do any kind of behavior you can imagine. It's far more sophisticated than a simple RESTful search or a simple create or update. But it does come at the cost that you need to get the systems involved to support the operation. Out of the box, most EHRs will support create and update and delete and search and stuff like that on most resources. They are not going to support a custom operation that you have defined locally within your space, unless you talk to them very nicely and probably pay them a bunch of money, which is how you get EHRs to do most things. Capitalism is wonderful. But that means that you use operations judiciously in situations where you can't accomplish what it is that you want using RESTful or similar mechanisms. Operations are there when the notion of a simple RESTful action is not going to accomplish what it is that you're trying to do. And let's then jump to a different implementation guide, which is going to talk about how do you decide what mechanism to use in sharing data with Fhir. This is something that is actually going to find its way into the core specification eventually, but we needed it sooner than that. There we go. This is a Davinci implementation guide. It was created by one of the accelerator projects. It's US-centric in theory, but the content that we're going to look at right now, there's a huge section under background called Approaches to Exchanging Fire Data. And that came about because Davinci has a whole bunch of different projects going on, and they were landing on different ways to share information, and not necessarily having a whole lot of clarity about why they were doing things differently, and weren't able to explain that well. There are 20-odd different ways that you can cause a target system to have data that they didn't have previously. And what this implementation guide does is it goes and provides a decision tree for how do you make a decision amongst all of the different ways for sharing information. And each one of these steps, so for example, human intervention, there is a whole walkthrough of why might you need human intervention in data sharing. Obviously, human intervention isn't something you desire, because humans cost money and software and hardware typically cost less. But there are a number of situations where you're going to need human intervention, and if you do, then you end up in a particular place in the decision tree. And so this is a pretty complex decision tree because there's an awful lot of different approaches to sharing data in Fire. Some of them are really broadly supported. So the notion of being able to do a RESTful search is pretty broad. On the other hand, being able to use Sparkle to query against a triple store because you've got your Fire data exposed in RDF is pretty darn rare. So we have a table up here that, sorry, I skipped past it, that talks about both how common is this particular mechanism in terms of existing implementations and how broadly applicable is it. So if you support read, is that going to be tied to a specific use case or is it going to be pretty general purpose? And the answer is read is widely supported and it's pretty use case agnostic. On the other hand, some of these down here at the bottom, like Fire messaging tends to be pretty use case specific. If you've got a Fire message interface and you come along with a new use case, you're probably going to have to write new code to support a new message structure and new messaging events. And you don't necessarily see a ton of support in the implementer space for messaging at all. And so those are considerations that you take into account together with the criteria in terms of what's going on in your space. So does the data already exist? Are you wanting to return resources or individual data elements? Is this ad hoc or is it nailed down? And that will help to guide you in making your decisions. We're not going to go through all of this because I could spend probably 4 hours going through the details of this chart by itself. But I wanted to let you know that it's here so that as you are trying to decide, we have this particular use case, how should we be using Fire to solve this use case? This will help to inform that decision. It's not a, you shall do this mechanism and only this mechanism or you're non-conformant. Fire doesn't work that way. It's more a question of what are the things that you should be thinking about in trying to figure out what's going to A, be the cheapest and easiest way to do this, and B, what's going to be the mechanism that is most in sync with how others will solve this problem and therefore increase the likelihood that I will interoperate with the partners that I'm trying to talk to. Okay, so that brings us to the end of Validator and terminology discussion. Any questions there.
Can you touch briefly on the topic of terminology servers? Do anybody actually use Fhir servers as terminology servers to do translations in production systems?
Yeah, so in Fhir, we actually have defined the expectations for a formal terminology service. So if you go to the Fhir website and you go into the terminology section, there is a formal definition of a terminology service. And that is a set of capabilities that an external system would have to do value set expansion, to do code translation, to do code validation. Is this in fact a valid code in this code system? Or is this a valid post-coordinated concept in SNOMED? And they're getting to be pretty robust. There are a number of commercial terminology services now available. They test themselves against each other at connectathons, and that's been going on for 7+ years. Terminology was one of the first places to do connectathon testing. And so, yes, it is absolutely viable to purchase, or there are open source ones as well, but some of the better ones are probably commercial. A terminology server to do some of this stuff for you, so you don't have to write the logic that understands SNOMED subsumption testing and post coordination and understands how to do that efficiently. So it's really nice to be able to do a search that says, find me all of the conditions that are diabetes or a specialization thereof. But doing that specialization test and having it come back in milliseconds is not an easy thing to do. And terminology services are designed to do that really efficiently, and to be able to consume the SNOMED updates and update their logic to do that consumption testing properly and that sort of thing. So yes, there are terminology services that can do this kind of thing for you. We're expecting over time that there will be other services defined in Fhir, like a conformance service that will do validation of content for you, and probably some other ones as well. But terminology is something that is already on the market.
And again, are there any specific vendors that you can think of?
Oh,
on the top of your head?
names. I know of several. I can see the people. I can't remember the names of their products. Ask on, there's actually a terminology stream on chat.fhir.org. And if you post the question there, you'll get an answer back probably within 5 minutes of what some of the major vendors are. My brain is not there right now. I was up too late watching election results. And I don't even live in the US. But yeah, OntoServer is one of them. Graham Grieve has one. There are a few others, and they're just not coming to mind. And I won't give you recommendations because I generally don't do that. Any other questions on terminology or validation? So the next thing I want to talk to you about is another implementation guide. This one is called International Patient Summary. This actually evolved out of some work from the World Health Organization, and it is a truly international implementation guide. So US core is obviously US specific. International Patient Summary, on the other hand, is very much not US specific. There's a whole bunch of people from a whole lot of countries, both large economies and small, that have been working on this implementation guide. And the notion behind it is, wouldn't it be nice if when you were traveling, you could bring your patient record with you and pass it to what the system of whatever hospital you end up getting admitted to because something bad happens on your vacation, and they could consume it and do useful things with it. And so International Patient Summary tries to provide a standardized representation of information that is portable across countries. And we're going to talk about a few things. One is that International Patient Summary uses Fhire's document approach to sharing information, which means that we're going to be packaging stuff up into bundles. So we'll talk about how that works and what you can and can't do when you package things together. We're going to look at Fhire documents in general, and we're also going to talk about narrative. So let's go find the International Patient Summary. Starts with finding my mouse. So again, if we go back to the Fhire homepage and go to these validation guides, yeah, unfortunately it looks from just this way. There we go. So this is the International Patient Summary, and it contains sort of the key information that you would want a clinician to know about when they are trying to provide care to you as you're crossing borders. So what are your allergies? What are your health conditions? What meds are you on? What vaccines have you had? What are your recent lab results? What are your recent surgeries? And then tying all of that together. And it uses an approach in Fhire called document, which basically means you're going to package up a whole bunch of resources. So we've got allergy intolerance, we've got procedure, we've got observation, we've got care plan, we've got other things. And we're going to package all of this up together in an organized way with the special resources at the top that lets us present information in a particular way. In particular, lets us present it to a human being. So we're wanting to tell a story of what's going on with this patient. And
Lloyd, and
yes.
in theory, the health passport that countries are talking right now, that in the context of COVID-19 would also be here, right?
Absolutely. Yeah. I don't know where they are at in terms of incorporating that into IPS, but yeah, that would be, you know, at minimum, you would have your immunizations. So when we actually have a vaccine, that would be captured there. And you would also have your lab results. So if you can show that you got antibodies, that would show up in your lab results.
Or serology reports or negative PCR.
Exactly.
Right?
Yep. All of that would show up there. And so this composition wrapper gives you who's the patient, who wrote this particular package of stuff, and who is saying that it is true. And you can tell that this is an international specification by the fact that they actually use non-US style quotation marks. And in the specification, they define a profile on the composition resource that describes what the content of this is. So there'll be an identifier and a status and what kind of document is this, and they're very specific in terms of you must say that it is this particular link code so you know it's an IPS, and who is the patient and that kind of stuff. And then they have a whole bunch of sections. So there's a section for medications that will point to medication statement. There's a section for allergies that will point to allergy intolerance. There's a section for problems that points to condition. And so this is a more sophisticated example of slicing, where there's one slice per section, and some of those sections, actually each of these sections is limited to only one repetition, but they can then contain a whole bunch of entries. So in this case, the diagnostic section includes both observations as well as diagnostic reports, so imaging information, that kind of stuff. And we've got vital signs, and we've got past illness history, functional status, care plan, social history, pregnancy. And this is intended to be usable across countries. So they try hard to not make use of terminologies that are country specific. So if we go to the profile on medication statement, which is a place where we don't typically have standardized terminologies, they will point to medication. And if we go to the medication, they allow either the WHO classification or they allow SNOMED. So WHO is free, SNOMED is more detailed, and they're saying we expect countries to be able to do at least one of these two things. And what that gives you, if we go look at the examples, is a bundle resource that says, hi, I'm a document. That's this particular type of bundle. And then we've got an entry for the composition. And it says who the patient is, who the author is, who attested, etc. And then there's references to problems and medications and allergies. And if we scroll further down, there are actually separate resources for each of those things, all packaged up together in this handy dandy bundle resource. And each one of these resources includes a narrative. That narrative should be showing up here. I discovered to my dismay when prepping for this presentation that it wasn't there because there's a bug in the publisher right now. But it turns out that I can go and generate that myself. So let me go and bring up the narrative that I built yesterday, which I thought I already had open, but apparently I closed down. By the way, somebody is drawing in yellow on my screen, and it would be nice if you didn't do that. So this is not terribly pretty because I don't have a style sheet, but this gives you a rendering of this from a human readable perspective. So even if you have a system that doesn't understand some of the discrete data, they can at least put this on the screen in front of a human being who can then look at it and understand what's going on with this particular patient. So that's what the document paradigm gives you. Documents were a pretty serious fad in healthcare, where everything that you wanted to share, you were going to package up into a CDA document and share it around. Turns out that documents are not necessarily the ideal way to package information and share it in a lot of circumstances. If I want to know the patient's current list of allergies as of now, I don't want to have to wade through 50 different documents and try to amalgamate the allergy lists from each of them, where one of them says that you have a serious allergy to penicillin, and one of them says you have an intolerance to penicillin, and one of them says that you have a refuted allergy to penicillin, and I have trouble understanding which of those things is true, and certainly cannot figure that out in the 10 seconds I have to look at your allergy list and figure out whether I should give you this drug or not. So I'm going to probably err on the side of caution and not give you a drug that could, in fact, be helpful to you because the information is confusing. Whereas if you've got access to the current list via REST, then it's pretty obvious what is true and what's not, because everybody's maintaining that source of truth, and you've got an integrated source of data. So let's go explore documents a little bit more. And I'm going to, actually, before I jump back to slides, let's go take a look at documents. Whoops, I didn't want to go to HL7. I'm going to go to Fhir. They put their hyperlinks on the wrong side. So one of the sections in Fhir is around documents. And there's a whole set of rules around documents in terms of attestation. You can sign documents. There's rules around how you need to render the content. And so all of that is documented there. But in summary, a document is going to look like this. So you start out with a composition resource. It's got a whole bunch of metadata on it in terms of title and author and date and all that kind of fun stuff. And then it's got a hierarchy of sections. And each of those sections will in turn point to a resource or sometimes a bunch of resources. And those resources might point to other resources. And you end up with a graph of interrelated information, but that graph is organized and navigated using the section hierarchy in the composition. And it's recursive, so you can have sections which have subsections, which have subsections if you want to, but usually 2 or 3 levels is enough to accomplish what you're looking for. And then that gets flattened out into a bundle of resources, which is the resource that we use for search results. We use it for messaging, we use it for various things. And it gives you a way to send a graph from one place to another, and the graph gets reassembled because all of the relationships exist in the pointers. So composition has sections which point to observation and list, and so you can reassemble that hierarchy by the nature of the pointers. One thing to be aware of is that there is no context conduction in Fhir. So the composition is going to point to the patient. The observation is also going to point to the patient. The list is going to point to the patient. The condition is going to point to the patient, because any one of these resources might get split out at some point and passed around by itself. And so it needs to tell the whole story, at least by reference. We can't presume that everything in the document is going to be about the same patient. And we can't presume that the author of the document is going to be the same as the author of the observation or the author of the condition. So every single resource points to its own context in terms of patient, author, encounter, etc., even if it's the same for all of them. But that's okay because it's just a reference. It's a simple little hyperlink. It's pretty lightweight. You're not sending a copy of the patient demographics every single time. The patient resource itself is only going to appear in that bundle once. In terms of when to use documents, documents are first and foremost about storage. You want to record a snapshot about the patient for a long period of time. So if you're doing a lab report, if you're doing a pathology report, if you're doing a discharge summary, those are all situations where you want, I mean, the discharge summary, somebody might look at it 20 years from now to figure out what happened during that surgery, because you're now experiencing abdominal pain and maybe that surgery you had 20 years ago is relevant. And so they want to take a look at that discharge summary, or they want to take a look at that surgical report. Documents don't actually drive workflow. So anybody could pick up a document at any time. So it's not a good way to drive somebody to take out a scalpel or start counting pills. If you want to have that happen and you still want to use documents, you need to wrap it with something else. The task resource is quite often used for that. Documents give you really tight rules over authentication because there's a rule about how to display the document. So you can be confident that when you are looking at the document that was signed by somebody, that you are seeing exactly the same content in the same order, in the same rendering that they saw when they signed off. Documents generally involve multiple resources. You don't generally have a document that only includes one medication request or something like that. And documents are also important or relevant when you generally have a single attester. So you've got a single set of information, you're freezing it at one point in time, and somebody is saying, yes, this is right. If you don't have those conditions, then documents may not be the appropriate solution. And so a lot of the places where we were using documents for CDA because they were the only mechanism for sharing that systems had, we are moving to RESTful query because it's actually more efficient, because the allergy list isn't necessarily attested to by one person, it's maintained by multiple people over time, and it's continuously changing, and we want to grab the current version of it. We don't want to grab a frozen snapshot. We don't care about what their allergies looked like 20 years ago. Usually we care about what the allergies look like as of right now. Every single resource in FHIR supports capturing human readable narrative. And that's particularly important when you're displaying information for a document, but it's actually important regardless. And I was actually somewhat disappointed when I was looking at the EPIC interface to find that they didn't populate narrative for all of their resources. And the reason that it's important is that when you share data, odds are pretty good that eventually that data is going to hit a system that's not going to understand all of the discrete information in the resource. So as an EHR, you're going to expose the data to a personal health record, and that's then going to expose it to maybe a payment system, and that's going to expose it to something else. And at some point in that chain, one of the systems is not going to understand some of the extensions, or is not going to even understand some of the core elements. And having a human readable view as a fallback is really helpful, because it means that if there's any important information in there, that it's going to get to the other human, even if they don't have a mechanism to understand it from a computable perspective. And so the strong recommendation is, even if you're doing something like real-time processing, so somebody sends you a claim and you're going to adjudicate it and return a response in less than a second, if you are storing that information and there's any possibility of that data propagating to other systems downstream later, hold on to the narrative and encourage narrative to be present, so that when that information does get shared and there's a possibility of humans needing to understand what's going on, that you have that human readable view. And narrative is basically just XHTML. There's nothing, it's not proprietary or anything like that. When you have narrative, there's a flag on it that tells you whether the narrative was manual, i.e. a human actually typed in what was to be displayed here, or was generated from the discrete data. Situations where you might have manual narrative are things like pathology reports, where the pathologist wants to have total control over exactly what's said, or sometimes maybe all you've got is narrative. So that care plan, the text of the care plan is the narrative for the resource. And maybe you don't have anything else. Your user interface is, here's a text box. If you are generating narrative, HL7 says that you need to include all the content needed for a human to understand the essential clinical and business information otherwise encoded in the resource. But we don't tell you what that is, because it varies by context. If you were going to have narrative for patient, it would typically include patient's name, patient's gender, patient's date of birth. But if you're a veterinary system and you deal primarily with birds, you might not have names, because the chickens don't have names and you don't really care. And so you probably would show the breed in your narrative, whereas we don't typically show the breed in the narrative for human patients. So it is left up to you to figure out what to include. And you will need to talk to your user community, because they will not only care what's in the narrative, they will care what order it's in and what color it's in and what's bold and what's a list and what's a table and all of those wonderful things. Don't go wild and crazy, because the narrative could be being rendered on a cell phone and rendered using various different HTML engines, and you don't want to include a whole bunch of style information that for some reason doesn't get rendered properly on a device, and that fancy column that you had that flags the lab report as critical suddenly doesn't show up, and somebody runs into trouble because of that. When you receive an instance that has narrative, you don't necessarily need to expose that to your end user, because if it was generated and you already know how to display all of the prescription information using your normal discrete elements, then there's nothing new or exciting in the narrative. On the other hand, if the narrative says that it was manually created, or the narrative says that it was generated using extensions and you don't recognize all the extensions, then you should probably provide access to the narrative as a fallback in case there's something important there that you don't know how to display. Any questions on documents? Then I'm going to jump to the next scenario, which is actually a Canadian system. It's one of the first FHIR messaging systems that hit production. And the purpose of showing this one off is to show you primarily what messaging looks like. So Prescribe-It is an e-pharmacy system, and it is also a FHIR implementation guide. It's much prettier than our usual implementation guides. It actually uses exactly the same tooling for publication that US Core and International Patient Summary use, but they had money to spend on pretty style sheets and smart JavaScript and stuff like that. And so it's a little bit nicer. The gist of Prescribe-It, actually, let me go and just show one of the interactions. Is probably the best thing to look at. They are transporting from one system. Where's my pretty diagram? I want a pretty diagram. Oh well. They wanted to be able to transmit prescriptions from a prescriber to a pharmacy via an intermediary. And so they use a messaging approach to make that happen. And because they want to be able to send who's the patient, who's the prescriber, what's the medication, what's the prescription, all of that as one package. They don't have RESTful interface to be able to query, because there was no expectation that the EHRs, the clinical EHRs involved, would have any ability to support query or even be up enough of the time to do that. And the same thing of the community pharmacy systems. So instead, there is a centralized system that sort of acts as a mailbox. And when the EHR is up, they post something to the pharmacy's mailbox, and that message sits there. And the pharmacy eventually goes and queries their mailbox and grabs the content and then deletes the message from their mailbox. This is an example of a message. So there's some profile declarations, and there's a message header that indicates who we're sending from and who we're sending to. And that then points to the task saying, here's what we want you to do. There's a reference to the patient. There is a reference to the practitioner, including a whole bunch of SAML stuff. So that's just incorporated as a blob inside the practitioner resource. We've got the organization who's doing the sending, and then we've got the prescription itself. So some extensions that convey dispenser instructions and other kinds of stuff that wasn't part of the core spec. We've got identifiers for both the sending system and the receiving system. We've got a reference to the patient. We've got our dosage instructions, and all of that gets transmitted as a single package that the pharmacy then says, okay, they've asked me to fill this. I know what to do, and I can respond and say, yes, done, or no, I can't do that, or whatever makes sense. If we go back to the specification, messages look kind of similar to documents in that they are a bundle of stuff, but instead of starting with a composition, which gives you a nice human readable table of contents, Messaging starts with a message header that says, here's who's sending, here's who's receiving, and here's the event that's going on that should drive your behavior. But other than that, the message has a focus that is the target of that particular event. And then from that, you then point to a whole bunch of other things that are relevant. And that gets flattened out into a bundle resource to transport from system A to system B. Messaging gives you an ability to do workflow. So documents won't do that, but messaging can. And it lets you do workflow that's more complex than just a simple create, read, update, delete. You could do everything that you do with messaging using operations though, and operations are lighter weight. So messaging typically gets used when there's a requirement for asynchronous or indirect exchange, where I don't necessarily know the address of the system that I'm trying to transport this to. So I'm transporting it via an intermediary who is eventually going to get it to where it needs to go. It's also relevant if you have systems that simply can't expose a RESTful interface because some of the data that they have doesn't have identity. If you've got a messaging backend and it's used to exposing a prescription and conveying the prescriber name and other information, but there's no formal way to query that practitioner in the system. It's always exposed in the context of a prescription. It's never exposed as providers by themselves. Then messaging might be the only way that you can expose that information. Any questions on messaging?
You scrolled briefly through the example, and there was a SAML blob there. Mm-hmm. So is it a bearer token? It's a way to digitally sign or in that case to provide identity of the practitioner who issued the prescription, right?
Yeah. Basically, it is used. I didn't design this particular part of the system, but my belief is that it's used to help in the authentication process, so that when you're addressing content to particular practitioners, that you know how to do that, and you can trust that they are who they say that they are.
Okay, in Israel, you actually have to digitally sign the prescription.
Right.
If it's...
That's not done in this particular situation, but you could. So down at the bottom of the bundle, there is an ability to include a signature entry and put in a full digital signature of the bundle itself. So that is certainly possible in Fhir. That wasn't an infrastructure that they needed for the prescribe it space. It was felt that if you authenticate to a trusted system and you have strong authentication that the prescriber is the person who's in fact posting this, and you know that nobody can mess around with the prescription inside the trusted system, that they didn't actually need to have digital signatures to make that work. And there's costs to managing the certificates for a full digital signature infrastructure. Yes. So they wanted to avoid that. And with their architecture, they could. But okay. If you need them, then yes, that's certainly possible. And there are systems that do use signatures, although not very many. We defined signature early on, but it took a long time before we got any feedback on it. All right, next up is, oh, never mind, I go back here. I want to talk about structured data capture, and specifically about the use of questionnaires in Fhir. And so I'm going to bring up a Smart on Fhir app. This was created by the National Library of Medicine in the US, but there's nothing terribly US specific about it. So this is actually Smart on Fire, it's running against a backend server, but running separate from the server. And I can go pick a particular patient that I want to interact with. And then I can go and grab a FHIR questionnaire. There's a whole bunch of them on this repository. I could also post my own if I wanted to go and try messing around with my own questionnaire. And this makes use of an implementation guide called Structured Data Capture. And one of the magical things about Structured Data Capture is it supports population. So it automatically fills in information into the form based on data stored in the EHR. That's an interesting date. So I'm not sure why they can grab gender. Perhaps they didn't have one for this particular patient. But it automatically fills in information into the questionnaire from the underlying EHR. So in addition to being able to store the questionnaire in the EHR, you can actually load data from the EHR as part of filling this out. And so you can then go in and pick your disease. And behind the scenes, this is actually hitting a terminology server. So as I'm typing, it is going and hitting the terminology server with a expand operation and saying, here's the text that the user has typed so far. Show me what the top 8 items are with that. And if I were to type cancer, it will again, this behind the scenes is automatically going off and hitting a terminology server. So I can then pick that and then go pick a value from the list of allowed answers. I can go and pick my relationship. And it will guide me in completing the questionnaire. Questionnaire is a mechanism that is a type of resource that FHIR supports that will let you capture anything. So you can capture medication information, allergy information, procedure information, care plan information, you name it. You can use questionnaires to capture practitioner details. You can use it to do elevator maintenance. It's pretty wide open. The power of questionnaire is that it gives you really tight control over user interface. The downfall of questionnaire is that it's not standardized. Anybody can create a form and they can gather any information they like in any way that they want. So it's really hard to search against a set of questionnaire responses and say, is this patient allergic to penicillin? Because you have no way of knowing what questions or what forms have that information or where it exists in the form, or even the fact that the form talks about a penicillin allergy. Is that a penicillin allergy of the patient, or is it a penicillin allergy of one of their relatives or something else? Because there's a whole bunch of context built up in the structure of the form that isn't necessarily obvious when you look at the answers. But this is an example of what a Smart on Fire application can do. The EHRs have generally shown not a whole lot of interest in supporting really complex forms because they got too much other stuff on their plates. But there's significant desire in the research community and the public health community and other places to have support for complex forms. And so we created a Smart on Fire application that lets you do all of that functionality without the EHRs having to worry about it. And it's the fact that they have that RESTful interface that lets us plug that content in, so we can store the questionnaire responses on that site, or possibly even just store a PDF rendering of the form on that site, but still have access to the full capabilities of questionnaire. Structured data capture specification has a whole bunch of, think of it as bonus material. The base FHIR specification deals with fairly simple questionnaires. SDC gives you a whole bunch of more advanced capabilities. So advanced rendering, form behavior like calculating scores and turning options on and off based on other answers, being able to populate forms automatically from existing data, adaptive forms like Promise, where you answer a question and then it tells you what the next question is, being able to extract information from forms into other resources. So I fill out a form and then it creates observations or conditions or allergy resources that can then be used in FHIR documents or that I can run statistics on and search for and find. In terms of advanced rendering, there's things like how do I display content that has formatting in it, or how do I do sliders and set mins and maxes, or how do I display information inside tables? How do I, there's an example somewhere here with pictures. There we go. So how are you feeling today? How do you embed something like that inside of a questionnaire? And for each one of those, there's a walkthrough of what does that actually look like inside of a questionnaire instance to make that type of form work. So that's an example of the kinds of things that you can do in an implementation guide, and a quick example of a Smart on FHIR app. And I'll take questions about that. As I feared, we are not going to get through all of these, so I'm just going to talk quickly to what this one is. Davinci implementation guides, there's a whole bunch of them that are driven by the US payer space, and they're focused primarily on improving efficiency of claims processing and getting information from one payer to another or from EHRs to payers. There's a particular set of implementation guides here that show you how implementation guides can work together. CRD makes use of a technology called CDS hooks to prompt a clinician as they are ordering a lab test or a medication or booking an appointment or whatever, say, hey, I as a payer have some information that you probably would appreciate, such as the drug that you're ordering isn't covered, or the drug that you're ordering is covered, but it's going to cost the patient $120 a month, whereas this one's going to only cost them $10 a month. Would you like to switch? Or you need prior authorization if you want that drug to get paid for. Here is a link to a form that you need to fill out in order to get prior authorization. DTR, it can be triggered by CRD, and it lets you launch a smart application to fill out all of the paperwork that a payer requires in terms of prior authorization or just documentation you need to have on hand, and automatically fill that out, leveraging information that already exists in the EHR. So minimizing the amount of work that the provider has to do to fill out that paperwork, and also ensuring that everything is filled out correctly. So you don't submit the form and then they kick it back and say, no, you didn't fill out that, or we're missing this or whatever. And it can be smart. So it only asks you for the information that it needs based on information it already has. And if the information is required in some circumstances and not others, it'll only ask you for it if that information is in fact needed in that situation. And then finally, PASS allows you to submit prior authorizations. There's regulation in the US that requires the use of X12 for doing prior authorizations, but a lot of the EHRs haven't bothered because they don't like it and they don't want to work with it. And so the PASS specification says, okay, well, if you won't use X12, maybe we can get you to use FHIR. And so we've mapped all of the X12 elements to FHIR, and you can then attach the paperwork that you completed using DTR, submit your prior authorization request. There's then a transformation that happens via an intermediary that turns that into X12. And in fact, there's an expectation that in some cases, the payers will actually transform the X12 back into FHIR to consume it using FHIR because there's some interest in them doing that. And maybe eventually the regulation requiring X12 will go away. But those are 3 implementation guides that work together. They can be used independently, but they also leverage each other. And they in turn are based on a common implementation guide called HREX, which is used across all of Davinci, which in turn is based on US Core. So it shows you how you can use implementation guide approach to stitch together a solution and build it up and have things play nicely together. There is some bonus content in the slide deck. I'm not going to go through all of it, but you can pursue it on your own. There may be recordings of me somewhere presenting some of it if you dig for them. But key message is Fhir has lots of capabilities. You can use it in a lot of different ways. Hopefully this is giving you a quick start and some things to